Hey everyone, I'm going to go over the first launch to Unit 8. This launch is going to be an introduction to confidence intervals and margin of error, and just talking about some of the concepts of confidence intervals and margin of error, and get you to explore these concepts. You're going to go ahead and watch the video first so that I can give you an overview of what the problem is talking about. Once I have done that, once I have done that, you're gonna pause the video to answer the questions, and then you're gonna watch it to get your answers. So complete the following problem to help you explore the ideas of confidence inferences and margin of error. It's okay if you are unsure. The point of this problem is to explore what you know and or thinking. You will be able to compare your answers afterwards. It might be more helpful to watch your launch video first to get an introduction to the problem. So in 1915, Einstein's theory predicted that the curvature of space, denoted by gamma, was 1, while Newtonian theory predicted it was 0. Since 1915, scientists have repeatedly found estimates of gamma using various methods and procedures. Each estimate has a margin of error, and the figure below displays that equation. So it would be estimate plus or minus the margin of error. So in this case, estimate would be the gamma from each of the 21 experiments. Note that each point is a gamma, and the line above and below each dot is the margin of error. So if I was to zoom in on one of these points, so let's say I'm using this box, this line right here, right? If I was to zoom into that, you're going to have a point, which represents gamma, and these are the margin of errors. Okay, so that's saying that gamma is between a certain interval plus or minus that point. Okay, you're going to go ahead and pause the video here. Try to answer A, B, and C. And then once you have completed that, you can go ahead and watch the video again to help you get the answers. Based on this display, describe how the precision of the estimates of gamma has changed over time. So looking back at this display, right, as you notice, over time, gamma starts to get more and more precise. And we say that because the margin of error is getting smaller and smaller. So over time, since the margin of error gets smaller, we get more precise at the estimate of gamma, right? So think of it like margin of error is how much room you get to make a mistake. The smaller the room of mistakes you can make, the more precise your answer has to be. B. Write a few sentences describing the strength of evidence that the experiment provided for the claim for Newtonian theory that gamma equals 0. Your response must include justification based on the display. So looking at the display, gamma equals 0 is here. Because none of these points cross at gamma equals 0, we actually have 0 points or 0 chances of this happening. So since each gamma on the graph never crosses 0, we have no evidence to support that gamma equals 0. Write a few sentences describing the strength of evidence that the experiment provide for the claim that Einstein's theory that gamma equals 1. Your response must provide justification based on the display. So now they're asking us how much of the evidence supports that gamma equals 1. So gamma equals 1 for this one, because it crosses at gamma equals 1. So here's gamma equals 1. It crosses 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of the 21 times. So, looking at the display, we have 18 out of 21 experiments crossing where gamma equals 1. So we have strong evidence that gamma could be 1.